paths in its architecture. 9. 64-bit address timeline. 1991 MIPS Computer Systems produces the first 64-bit microprocessor, the R4000, which implements the MIPS 3 architecture, the third revision of its MIPS architecture. 10. The CPU is used in SGI graphics workstations starting with the Iris Crimson. Kendall Square Research deliver their first KSR-1 supercomputer, based on a proprietary 64-bit RISC processor architecture running OSF/1. 1992. Digital Equipment Corporation, December, introduces the pure 64-bit Alpha architecture which was born from the Prism project. 11. 1994 Intel announces plans for the 64-bit IA64 architecture, jointly developed with Hewlett-Packard, as a successor to its 32-bit IA32 processors. A 1998 to 1999 launch date wastegated. 1995 Sun launches a 64-bit Spark processor, the Ultra SPARC. 12. Fujitsu-owned HAL Computer Systems launches workstations based on a 64-bit CPU, HAL's independent Lie designed first-generation Spark 64. IBM releases the A10 and A30 microprocessors, first 64-bit PowerPC as processors. 13. IBM also releases a 64-bit as /400 system upgrade, which can convert the operating system, database and applications. 1996 Nintendo introduces the Nintendo 64 video game console, built around a low-cost variant of the MIPS R4000. HP releases the first implementation of its 64-bit PowerISC 2.0 architecture, the PAR 8000. 14. 1998 IBM releases the Power 3 line of full 64-bit PowerPC /Power processors. 15. 1999 Intel releases the instruction set for the IA64 architecture. AMD publicly discloses its set of 64-bit extensions to IA32, called x86-64, later branded AMD 64. 2000 IBM ships its first 64-bit Z/architecture mainframe, the Z Series Z900. Z/architecture is a 64-bit version of the 32-bit SR/390 architecture, a descendant of the 32-bit System/360 architecture. 2001 Intel ships its IA64 processor line, after repeated delays in getting to market. Now branded Titanium and targeting high-end servers, sales fail to meet expectations. 2003 AMD introduces its Optron and Athlon 64 processor lines, based on its AMD 64 architecture, which is the first x86-based 64-bit processor architecture. Apple also ships the 64-bit G5 PowerPC 970 CPU produced by IBM. Intel maintains that its Itanium chips would remain its only 64-bit processors. 2004 Intel, reacting to the market success of AMD, admits it has been developing a clone of the AMD 64 extensions named IA32E, later renamed M64T, then yet again renamed to Intel 64. Intel ships updated versions of its Xeon and Pentium 4 processor families supporting the new 64-bit instruction set. VIA Technologies announces the Isaiah 64-bit processor. 16. 2006 Sony, IBM, and Toshiba begin manufacturing the 64-bit cell processor for use in the PlayStation 3, servers, workstations, and other appliances. Intel released Core 2 Duo's first mainstream x86-64 processor for its mobile, desktop, and workstation line. Prior 64-bit extension processor lines were not widely available in the consumer retail market. Most of 64-bit Pentium 4/D were OEM, 64-bit Pentium 4, Pentium D, and Celeron were not into mass production until late 2006 due to poor yield issue. Most of good yield wafers were targeted at server and mainframe, while mainstream still remain 130 nm 32-bit processor line until 2006, and soon became low-end after Core 2 debuted. AMD released the first 64-bit mobile processor and manufactured in 90 nm. 2011 ARM Holdings announces ARMv8, the first 64-bit version of the ARM architecture. 17. 2012 ARM Holdings announced their Cortex-A53 and Cortex-A57 cores. Their first cores based on their 64-bit architecture, on the 30th of October 2012. 18. 2013 Apple announces the iPhone 5S, with the world's first 64-bit processor in a smartphone which uses their A7 ARMv8-based system on a chip. 2014 Google announces the Nexus 9 tablet, the first Android device to run on the 64-bit K1 chip. 64-bit operating system timeline. 1985 Cray releases Unicos, the first 64-bit implementation of the Unix operating system. 1993 December releases the 64-bit December OSF/1AXP Unix-like operating system, later renamed True 64 Unix, for its systems based on the Alpha architecture. 1994 Support for the R8000 processor is added by Silicon Graphics to the IRIX operating system in Release 6.0. 1995 December releases OpenVMS 7.0, the first full 64-bit version of OpenVMS for Alpha. First 64-bit Linux distribution for the Alpha architecture is released. 20. 1996 Support for the R4X00 processors in 64-bit mode is added by Silicon Graphics to the IRIX operating system in Release 6.2. 1998 Sun releases Solaris 7, with full 64-bit Ultra SPARC support. 2000 IBM releases Z/OS, a 64-bit operating system descended from MVS, for the new Z series 64-bit mainframes. 64-bit Linux on Z systems follows the CPU release almost immediately. 2001 Linux becomes the first OS kernel to fully support x86-64 on a simulator, as no x86-64 processors had been released yet. 21. 2001 Microsoft releases Windows XP 64-bit edition for the Itanium's IA64 architecture. It could run 32-bit applications through an execution layer. 2003 Apple releases its Mac OS X 10.3 Panther operating system, which adds support for native 64-bit integer arithmetic on PowerPC 970 processors. 22. Several Linux distributions release with support for AMD 64. FreeBSD releases with support for AMD 64. 2005 On January 4th, Microsoft discontinues Windows XP 64-bit edition, as no PCs with IA64 processors had been available since the previous September, and announces that it is developing x86-64 versions of Windows to replace it. 23. On the 31st of January, Sun releases Solaris 10 with support for AMD 64 and M64T processors. On the 29th of April, Apple releases Mac OS X 10.4 Tiger, which provides limited support for 64-bit command line applications on machines with PowerPC 970 processors. Later versions for Intel-based Macs supported 64-bit command line applications on Macs with M64T processors. On April 30, Microsoft releases Windows XP Professional x64 Edition and Windows Server 2003 x64 Edition for AMD 64 and M64T processors. 24. 2006 Microsoft releases Windows Vista, including a 64-bit version for AMD 64/M64 processors that retains 32-bit compatibility. In the 64-bit version, all Windows applications and components are 64-bit, although many also have their 32-bit versions included for compatibility with plugins. 2007 Apple releases Mac OS X 10.5 Leopard, which fully supports 64-bit applications on machines with PowerPC 970 or M64T processors. 2009 Microsoft releases Windows 7, which, like Windows Vista, includes a full 64-bit version for AMD 64/Intel 64 processors. Most new computers are loaded by default with a 64-bit version. Microsoft also releases Windows Server 2008 R2, which is the first 64-bit own-Live operating system. Apple releases Mac OS X 10.6 Snow Leopard, which ships with a 64-bit kernel for AMD 64/Intel 64 processors, although only certain recent models of Apple computers will run the 64-bit kernel by default. Most applications bundled with Mac OS X 10.6 are now also 64-bit. 2011 Apple releases Mac OS X 10.7 Lion, which runs the 64-bit kernel by default on supported machines. Older machines that are unable to run the 64-bit kernel run the 32-bit kernel, but, as with earlier releases, can still run 64-bit applications. Lion does not support machines with 32-bit processors. Nearly all applications bundled with Mac OS X 10.7 are now also 64-bit, including iTunes. 2012 Microsoft releases Windows 8, which supports UEFI Class 3, UEFI without CSM, and Secure Boot. 2013 Apple releases iOS 7, which, on machines with ARM64 processors, has a 64-bit kernel that supports 64-bit applications. 2014 Google releases Android Lollipop, the first version of the Android operating system with support for 64-bit processors. 2017 Apple releases iOS 11, supporting only machines with ARM64 processors. It has a 64-bit kernel that only supports 64-bit applications. 32-bit applications are no longer compatible. 2019 Apple releases Mac OS 10.15 Catalina, dropping support for 32-bit Intel applications. 2021 Google releases Android 12, dropping support for 32-bit applications. Microsoft releases Windows 11 on October the 5th, which only supports 64-bit systems, dropping support for IA32 systems. Limits of processors. In principle, a 64-bit microprocessor can address 16 EIB, 1010246 equals 264 equals 18,446,743,709,551,616 bytes, or about 18.4 exabytes, of memory. However, note all instruction sets, and not all processors implementing those instruction sets, support a full 64-bit virtual or physical address space. The x86-64 architecture, as of 2016, allows 48 bits for virtual memory and, for any given processor, up to 52 bits for physical memory. 27. These limits allow memory sizes of 256 TB, 256 10,244 bytes, and 4 PB, for 10,245 bytes, respectively. A PC cannot currently contain 4 PB of memory, due to the physical size of the memory chips. but AMD envisioned large servers, shared memory clusters, and other uses of physical address space that might approach this in the foreseeable future. Thus the 52-bit physical address provides ample room for expansion while not incurring the cost of implementing full 64-bit physical addresses. Similarly, the 48-bit virtual address space was designed to provide 65,536, 216, times 32-bit limit of 4 GB, for 10,243 bytes, allowing room for later expansion and incurring no overhead of translating full 64-bit addresses. The Power ISA version 3.0 allows 64 bits for an effective address, mapped to a segmented address with between 65 and 78 bits allowed, for virtual memory, and, for any given processor, up to 60 bits for physical memory. 28. The Oracle SPARC Architecture 2015 allows 64 bits for virtual memory and, for any given processor, between 40 and 56 bits for physical memory. 29. The ARM ARCH64 Virtual Memory System Architecture allows 48 bits for virtual memory and, for any given processor, from 32 to 48 bits for physical memory. 30. The December Alpha specification requires minimum of 43 bits of virtual memory address space, 8 TB, to be supported, and hardware need to check and trap if the remaining unsupported bits are 0, to support compatibility on future processors. Alpha 21064 supported 43 bits of virtual memory address space, 8 TB, and 34 bits of physical memory address space, 16 GB. Alpha 21164 supported 43 bits of virtual memory address space, 8 TB, and 40 bits of physical memory address space, 1 TB. Alpha 21264 supported user-configurable 43 or 48 bits of virtual memory address space, 8 TB or 250, supported 43 bits of virtual memory address space. Underlying architecture. Java programs that run on a 64-bit Java virtual machine have access to a larger address space. 33. Speed is not the only factor to consider in compare.
Yes, now I did it again. I was clicking the document. That happens when I'm sleepy. When I'm clicking, it stopped reading. But let's read this page again. We have to read page by page. That's because I'm getting sleepy. Then I'm mistake. I'm clicking my mouse. And if you're clicking the mouse when you're reading, it stops reading. So, and I have a video I need to get online. Yes. Now it's 2:50. I think I should think about to cook some hot food. No, I have a video is ready. It's because it's a little bit hot in my apartment always, so I'm getting sleepy. Yes, now the 32-bit computing is public. And let me add it to the playlists. Normally I do that when I'm finished, but now I'll make this stupid mistake. So let's just finish at this. Good. But of course I cannot remember all this information. That's too many information, too many numbers. No, that's always a little bit hot in my apartment. But now the sun is shining. Let's get some more lemonade. So that's because when I'm sleepy I'm clicking on my mouse and if you clicking your mouse, you interrupt the auto reads. The auto read will stop if you click the mouse. Yes, I'm used just to have my fingers